Alright, on number 35, I have these two intersecting chords, and I want to just remember that, let's say this one's A and B, and this is C and D. A over C, if I do the ratio of A over C, that should equal the ratio of B over D. And if I cross multiply those, that means like AD equals BC. So that's like the two segments of the straight lines multiplied together are equal. Another way to think about it is like if I have two triangles here, okay, like this triangle and this triangle, those two are going to be similar triangles because, first of all, those two angles have to be the same because they're intercepting the same arc. But then also these two angles in here have to be the same because they're vertical angles. So anyway, so my 18 and my x will be corresponding sides on a triangle, and so will the 27 and the 30. So if I do 27 over 18, that's going to equal 30 over x. And I can multiply both sides by x and get 27x over 18 equals 30. And I'm going to reduce this 27 over x here to 3 over 2. Or sorry, 27 over 18 to 3 over 2. So we have 3x over 2 equals 30. Multiply the 2 to the right side. 3x equals 60, so I get x equals 20. Alright, on this next one, I'm going to set up my ratio again. 14 over 2x minus 5 equals 16 over x plus 11. And let's cross multiply. 14 times x equals 16. Okay. And then I just need to remember that, you know, setting it up like that, that's just me envisioning two similar triangles. But doing it this other way, that's something that you'll see it on the internet if you look up the formula for this. So either way works. Okay, I'm going to divide both sides by 14. I get x plus 11 equals, if I reduce those, that's 8/7, 2x minus 5. If I distribute in my 8/7, x plus 11 equals 16 over 7, x minus 40 over 7. Ugh! Okay, this is getting so crusty with these sevens on the bottom, actually. So what I'm going to do is I'm going to just multiply both sides by 7, because you might remember this being called a fraction buster in Algebra 1. If I multiply this side by 7 and this side by 7, I get 7x plus 11, or 7x plus 77 on the left. I'm going to get 16x minus 40 on the right. Okay, that feels way better. And then I'm going to subtract my 7x. And I get 77 equals 9x minus 40. And then I'll add 40. 117 equals 9x. Alright, so I have to divide by 9. And I get x equals, I don't have my calculator with me, which is really ridiculous because I'm doing math right now. Let me just take a 9 out. I get 27 here. Okay, oh sweet. It comes out evenly. Yay. X equals 13. And I just wrote all over number 38, so whoops. Okay, so for this one, x equals 13. I'll come back through and get rid of this stuff. Coolio. Alright, number 37. This formula, 6 times the whole side here is going to be equivalent to 7 times the whole side here. This is, again, because of similar triangles. It's just, the proof behind it is a little funky because it's not the layout you would expect. So if you want me to do the proof with you, get on Zoom. I'd love to. It's kind of interesting. But if you don't want to know what the proof is, then you should probably write down these formulas because they're not the most intuitive thing in the world. Okay. 6 times 21 is 126 equals 49. 7 times 7 is a football team. 49ers. Plus 7x. That was what I was told in 3rd grade, so I don't know. I don't even know if the 49ers are still a team. Google it. Alright. 26 minus 49. I'm gonna get a 7 here. And then a 7 here. Okay. Ooh, nice. Divide by 7. And I get 11 equals x. Cool. And then on 38, the side of the 18 doesn't have a full side here, so it's just going to be 18 times 18 equals 12 times 12 plus x. Which is no big deal. I'm going to pause and get these numbers here. And then, okay, so I got my 18 squared is 324. Instead of distributing that 12 in, I'm just going to divide both sides by 12 instead. Divide by 12, divide by 12. 324 divided by 12 is 27 equals 12 plus x. Something plus x equals 27. Turns out that number is, spoiler alert, 15. 15 equals x.